All right. A firm does a random test of 60 students throughout the United States. Hey, were you here yesterday? Okay. I had forgotten to take roll and I marked you absent. I was like, I couldn't. So I marked you absent, and then I was like, oh no, I got to make sure you're right. So far, says a firm does a random test of 60 students throughout the United States. A sample, they find an average of 22 and a standard deviation of 1.2 is normally distributed. Making 95% confidence interval, interpret the meeting. What happens if they make a 40% confidence interval? Okay. So, is this a normal distribution or is it a t-distribution, and why? One thing I want you to note, okay? What are the two items that go for a t-test? Sample size is less than 30, but what was the other one? What was the other thing for a t-test? It says of the sample, they find an average of 22 and a standard deviation of 1.2. It does say it's normally distributed, but they are doing the standard deviation based on the sample. We didn't know the overall. So this, my friends, has to be a t-distribution. Okay? Does that make sense? Okay? We satisfied the more than 30 students, which is great, but the standard deviation being it came from the sample means it has to go become a t-distribution and not a normal distribution. Does that make sense? So I just want to make sure if you see a curveball like that, that might be something to look at. Now, if they tell you that, we already know that the overall standard deviation of the entire population is something, that's great. As long as we're above 30 students, we'll use a normal distribution, but we'll use a T one on this one.
Okay.
I know my ears are ringing, but is it loud in the hallway right now?
Yeah.
Okay. All right. So we know we have this. We know we have this.
Okay. Time walking is 5. Okay, and now run up the stairs.
There's stairs throughout campus, and they choose the ones outside my door. All right.
Okay, we're done.
Let's see. So we want to do this two ways. We want to do the 95%, and then we want to do the 40%. Good? All right, so what are we going to do? How do we go about this problem? First thing, we got to turn to Desmos, right? Well, I just need to get Desmos on. All right. So confidence interval. Let's find our confidence interval. So we understand that we're using a t distribution. That's going to be t times the standard deviation over the square root of the sample size. Okay? So we're going to use this to find our margin of error. All right. So let's figure out t. We need to figure out t. So we're going to plug in, what would our degrees of freedom be on this one?
21.
Nope. 59. One less than our sample. One less than that. Okay. All right. So t distribution. Boom, boom. You guys all know where to find this? Yeah, we'll find the 95 first. What did we say? 59 was their degrees of freedom? And then period. And then go back into functions and look for inverse CDF. So halfway to 100 is 97, 0.975? Cool. All right. So what do we do after that? Plug it in. So that 2, so this happened to come out really nicely of two t distributions. So we're just going to use 2. So that's 2 times our standard deviation, which is 1.2, divided by the square root of 60. Okay? Did you get an answer on that? 0.31. So 31%. 31%, 0.31. What's that? Okay, so then this will be 22 plus or minus 0.31. So that's what, 21.69 to 22.31.
What page is
This, I'm just made this up.
Oh.
All right, so this goes along with the 95%. Okay, so this is how I want you to word this. I want you to think about how I'm saying this in the words. Because of what we talked about yesterday, this means that we are 95% confident, but I want you to say it this way. This means if we did 100 samples of 100 random samples of 60 students throughout the United States, that 95 out of 100 of our tests would fall within our confidence interval. Okay? Now, if I change this to the 40%, okay, if I change it to the 40%, I'll go blue here. So then I'm going to change a couple things. So I have to go find the margin of error with this t standard deviation will still be the same as 1.2 divided by root 60, but I have to find the new t value. You got it? What'd you get?
0.52. 0.53. Because it's 0.70. It's 40%, 60 plus 70, and plus 30, so 0.7.
Yeah, 0.70. Good. So 40, halfway to 100 from 40 is 70, right?
Oh, wait, 60 going to divide that by 60 is 30, so 30.
Yeah, 30. Okay? So if we plug the 30 in, plug the 70 in here, right? 0.53? Cool. So that's going to change this to 0.53 times the 1.2 over root 60.
I got 0.08.
Point what?
0.82.
Okay, so then this is going to change it to this is going to change it to 21 point. What's 1 minus? What's 22 minus 0.082? 21.017? Did I do that right? And then the other one, and then is what? And then 22.08? Oh, crud, look what happened. 22, that's a 22.08. Okay, so when I go to a 40%, my margin of error starts getting closer and closer. Okay? So what we would say in this case is we're 40% confident that if I took another 100 random samples of 60 students, 40 out of 100 of them would fall within this parameter. Okay, yeah.
Like, when did you use the 59?
When I use the 59.
For like 60 minus 1.
Where are you saying 60 minus 1?
Like the t distribution. Right? You have to find the,
Blue or red?
just this problem in general. Like 60 minus 1, what was I before?
Which part are you looking at?
You know when you have the sample size minus 1,
Yes.
is like what is I before?
Oh, that's when we do the t-distribution here.
Oh, okay.
So t-distribution, one less in our sample is degrees of freedom. Okay. All right. Now you have to reset this, reopen it. All right. So my next problem I want to look at. The next problem says, a cell phone is being developed and a company does a random survey of 12 individuals. They find the standard deviation of 1.7 from the number of apps on phones today from a national database. Okay? So is this a t-distribution or is this a normal distribution? It's t. This case is a t-distribution because they do a random survey of only 12 people. Okay? The standard deviation that's given here is actually the standard deviation of the entire national average. They want to make a 99.9% confidence interval. Okay, so we have a sample of 12. We have a standard deviation of 1.7 from national database. This is still going to be used the same way, but this is a t-distribution based on that's there. So my degrees of freedom, it's going to be 11. And so we have t, so my margin of error is t equals times standard deviation over root n. So we have to find t. Standard deviation, we said, is 1.7 over the square root of 12. So if we plug this in,
I got 3.1. Well, 3.105. Do you want around 3.8?
3.1 sounds good. So 3.1 times 1.7 over root 12. What'd you get?
$1.52.
1.52. All right. So this is going to be 12 plus or minus 1.52. Did you miss a step?
No, I messed up the T.
What'd you get for t?
99.9. I put in 9.995, but it's 0.9995.
Yes, 0.9995.
So it's 4.4. 4.44.
4.44. Cool. So,
And then the normal is 2.18.
oh, this should have been 4.44.
Yeah.
And then what was the over?
2.18.
2.18. All right. So this is dorking up on me again. So I just do this. So
Unless I'm tripping, we can check.
no, you're probably right. Let me just do this here. What are we're going 0.9995.
Well, no, it's 11.
Oh, 11 is my degrees freedom thing. I plugged in the wrong spot. 11.9995. That's halfway to 100 from 99.9. So 4.4. So I'm going to go 4.4 times 1.2 divided by the square root of 12.
It's 1.7. That is 1.7.
Did I plug in wrong? It's 1.7. 1.7. I just 1.7. 2.16. All right. So what are we going to deal with here? Where does this 2.15 go in? What do we add or subtract it to? What do we add and subtract here?
It's 1.52.
Ah. How do we get our confidence interval on this? All right, so basically what's taking place here we do not know how many apps are on the phones. Okay? But what we do know is we have some parameter, but we know that we're going to range between 2.15 either direction and based on 0. Okay? So that's kind of a goofy one to think about. I probably won't give this. I'll make sure I have the sample size in there. I didn't have that. But I forgot to put a sample size in there. But that would be basically mean. So my point on the 99.5, my point on the 99.9 is, would we trust this set? Would we trust the 99.9%?
Yeah.
What do you think?
Well, it would also depend, it would depend where the, what's it called? It's Congress.
Yeah, if I knew how many apps were on a phone, I forgot to put that in there. But I would not trust a 99.9% because it's going to be so wide.
Because everything's in it.
Yeah, you said everything could happen here. I mean, you have a 0.1% chance of it falling outside of it, so gotta be careful. Is the Wi-Fi jacked up right now?
Yes, yes.
If you get that,
I
then you
can't-
take
I can't even play Minecraft.
The disparities are.
Well, you know what we gotta do? We're trying to beat the Ender Dragon, man.
All right. So if you take a look at this one, what is the margin of error if I had a confidence interval from 40 to 60? What is my what's my margin of error? Plus or minus 1?
Dude, my regular.
50 is my point of estimate, because halfway. Margin of error would be 10 going each direction. Okay, does that make sense, friends?
Oh, because you're going, yeah, I got you.
So your point of estimate is halfway in between the confidence interval, and then you figure out how far above and below that middle value you'd go. So it's plus or minus 10 in this case.
Gotcha.
Okay? And then if I have a critical value of 1.57, I have to look this up real quick.
Oh, that's someone's guy.
The confidence interval of 1.57.
I just do the Wi-Fi. You can tell them that the Wi-Fi. Give the kids their Wi-Fi.
All right. All right. So if I gave you a critical value of 1.57, what is the meaning of this? It's the difference between the point estimate and the highest value in the interval. Okay, that's what's going to be taking place there.
Wait, what?
So this is the difference between the point estimate and the highest value of the interval. You ready? So if I had a critical value of 1.57, what is the meaning of this? Basically means it's the difference between the point estimate and the highest value in the interval. Technically, it's the highest and lowest, but if you only have one direction, it's the highest. The difference between the point estimate and the highest value of the interval. So if we knew we had like 40, it'd be 40 plus 1.57, and 40 minus 1.57 is basically what it is. What's the meaning of a parameter? What's a parameter?
The outside.
Kind of. The parameter is the value that our confidence interval is trying to capture a parameter. We don't know what our parameter is, but we have a confidence interval. Like we did one thing and we said, hey, we had a mean of 26, and then we did it again and we found our confidence interval. We might think that 26 might be our parameter, but it's unknown because remember on our t-distribution when you had the vertical lines, your parameter is basically where something would fall in between. It's where your mean would basically fall. Okay? And then these equations would probably be pretty important for you to recall. Okay? So if you have all of that information,